Okay, so far we have learned how to construct compound Boolean expressions from simpler parts using things like numerical operations like plus, minus, multiply, and divide, also Boolean operations like and, or, and not, and also these logical connectors such as the double equal sign, not equals, greater than, and less than. But we're not done because, as we saw, there could be some ambiguity related to the order in which we execute these operations. So, for example, if we have -2 asterisk asterisk 2, does that mean that we want to evaluate 2 squared, which is 4, and then take the negative of that, thereby giving us -4? Or does it mean that we want to evaluate -2 and then take the square of that, so -2 squared would give us +4? You see, it makes a difference whether we evaluate the exponentiation before the negation or the negative before the exponentiation. So the order in which you evaluate the operators is called the operator precedence, and that's what we're going to review now. This table essentially summarizes the whole topic. It gives us the precedence or the priority with which operators are evaluated from the highest priority at 1 down to the lowest priority at 9. And at the top you see that the highest priority is parentheses or a grouping. And so what that means is that the Python interpreter is going to search for parentheses and it's going to focus in and evaluate that part first. And in fact, it will do this recursively and go into the innermost parentheses. After the parentheses come the numerical arithmetic operations. And the highest priority amongst those is exponentiation, and then taking the negative. And we hadn't before mentioned the negative as a numerical operation, but, well, there it is. Then we have the multiplicative operations such as times, divide, the quotient, and the modulus. And then the additive operations like plus and minus. And then come in sixth place the logical comparisons. So less than, equal, equals, and so forth. And then come behind those all of the Boolean operations. And highest priority amongst those is the not, which is the negation. And then come and then or. And, well, conjunction is just another fancy name for and disjunction is a fancy name for or. So this may seem like a lot to keep in your mind to memorize this table, but it actually, after you do a few exercises with this and you get used to it, it becomes pretty second nature quickly. Let's look at an example of it. So let's take these two lines of code. The first one defines a with a value of 2, and the second one is just a Boolean expression, a long Boolean expression, and it's pretty complicated, so it's not very clear what the result is going to be. We'll have to look more carefully at this expression. Okay, so here's our code. And what we're going to do next is we are, in a sense, going to get into the mind of the interpreter and see how it evaluates this expression step by step. And I have color-coded things here so that what is in pink is items that are already resolved, and what is in black are items that are yet to be resolved. So let's see how this goes. The first thing that the interpreter is going to do is it is going to resolve the numerical values or the constants and the variables. So numerical values like 20, this gets resolved to a 20. 2 becomes a 2. 5 becomes a 5. 5 becomes a 5. And then we have this variable a whose value is 2. So this becomes a 2, and a gets replaced with a 2. That's step 1, or that was step 0. Now we're going to do step 1. And now we have unresolved still the not, this multiplication, parentheses, and so forth. And when we go to our operator precedence table, we see that at the very highest priority is we have to deal with the parentheses. So what's inside these parentheses? We have negative 2 exponentiation 2. And so that's 2 operators. Which one do we do first? We go to our table, and our table tells us that exponentiation comes before taking a negative. So that's what we have to do. We see this exponentiation has a 2 to the left and a 2 to the right. So 2 squared gets resolved to 4. And still this negative is there. So that was step 1. Now, we still are not done with the parentheses. We should resolve the negative. So a negative applied to the 4 resolves to negative 4. That was step 2. All right, now we see what is in the parentheses is completely resolved. So we can resolve the parenthesis itself, and so it disappears, and we just have a negative 4 there. Now we're looking at this expression. There are 5 elements that remain unresolved. There's a not, a multiplication, a greater than or equal, an or, and a greater than. Which one to do first? Go to our operator precedence table, and we find that the highest in the table is the multiplication. So that's the one that we have to do first. To the left there's a 20, to the right there's a negative 4. 20 times negative 4 resolves to negative 80. Okay, still a few to go. So now we have a not and an or, and we have 2 comparison operators. So the comparison operators are higher precedence, but these 2, the greater than or equal and the greater than, are equal in their priority. So it really doesn't matter which one we do first. I'm just going to elect to do the greater than or equal first. So is negative 80 greater than or equal to 5? No. So this evaluates to false. And then we evaluate the other comparison operator. Is 2 greater than 5? No. So this evaluates to false. Now we have left only a not and an or. And in the table, not is above or. So we do not false first. Not false is true. And then true or false, we look at our truth table, we find that that is equal to true. So we have finished boiling this big compound expression down to the value true.